Hello and happy Monday. Our science today we're talking about groundwater and geology. This is 14.3 in your textbook. Hope you all had a wonderful weekend. This is also day 5, so if you get up through this point and you've done your review after today, feel free to take Tuesday and Wednesday off. Alright, minerals in groundwater. When water evaporates to become water vapor, it leaves impurities behind. Rainwater is usually clean, so anytime that water is evaporated, it just pulls the water up into water vapor. Anything that's left behind, salts, minerals, are too heavy and they can't go with it. So this rainwater is clean. It has no dissolved materials in it. When it seeps into the ground, it carries minerals from the topsoil, and then it dissolves minerals on its way down. These minerals then get carried down into the groundwater, into these aquifers. Hard water. When groundwater has a large amount of dissolved ions for minerals, it is called hard water. Remember, ions are elements that are positive or charged. Calcium ions are the most common ion in hard water, although you also have iron and magnesium, and these all react with soap and prevent it from forming suds. On the picture on the right there, you can see soft water has all that bubbles in the top of it on the left there, and then on the right you have the hard water and there's no bubbles. You can see it's kind of cloudy. That water is hard. You can test it with your water too. If your water does not form bubbles, it's probably harder water. Not necessarily bad, just means it has more minerals in it. Artesian water, this is the stuff that's trapped in between those two impermeable layers. It's harder than groundwater because it has to travel further, it can't get out, and it usually will be warmer. Warmer water, of course, dissolves more minerals. Mineral deposits by groundwater. Mineral deposits, these are deposits of minerals left by cooling or the evaporation of groundwater. On the right here I have an example of geyserite. As the water from down inside the earth rises, it dissolves igneous rock, and this gets expelled out of geysers. The silica from this igneous rock then is deposited around the geyser, and this is what this geyserite is. It kind of looks gray and chalky, but it's that silica, that silicon and oxygen mix. Petrified wood. These form when minerals dissolved in groundwater replace the decaying wood of buried trees. This happens very slowly. As each tiny piece of wood is replaced by mineral, the tree retains most of its appearance. This usually happens to trees that are covered in ash from volcanoes, ones that are underwater. It doesn't usually happen to trees that just fall down in the forest because they usually aren't subject to the minerals and they dissolve too quickly. These can form large forests of petrified wood, though. On the right there I have an example of a large forest of petrified wood. The top is a really pretty example of petrified wood being replaced by minerals. Cementing. When we talked about sedimentary rocks, we talked about the cement that puts them together. This occurs because of this groundwater carrying minerals such as calcite or silica. Over time, more and more calcite is deposited, forming conglomerate rock. Mineral springs. Mineral springs is one that has a high concentration of mineral matter. They can be formed by water passing through rock with easily dissolved minerals such as limestone, water that has quantities of gases that form acids when mixed with water. This is like that igneous rock. Water is hot, and hot water dissolves rock more easily. Travertine, this is deposits formed by minerals at mineral springs. This on the right is a big example of travertine deposited at Yellowstone National Park. Caverns, not caves. Limestone is common bedrock. It's made, of course, you guys remember the calcium carbonate in limestone is from seashells. It dissolves easily, and it dissolves more easily than a lot of type of rock. This is dissolved by carbonic acid found in groundwater, found in acid rain. So acid rain speeds this process up. Dissolving parts of limestone increases its porosity. These pores get bigger inside of the limestone, these already existing pores. After hundreds of years, as these pores continue to get larger, you get these large network of caverns from these pores as water flows through them and forms these big old caves. Cavern features dripstone. This is a calcite deposit formed from dripping water in caverns. can only form when the cavern is at or above the water table. If it's below the water table, it will be underwater. Stalactites hang like icicles from the roof, and stalagmites form from the ground up. The way I remember the difference between these two is stalactites has more letters that are tall, so it's on the roof. Stalagmites has more short letters, so it's on the floor. A column, in the right here I have an example of two columns. They form when stalagmites and stalactites grow together and become one structure from the ground up. Karst topography. This is any region that has a sinkhole ponds, that's a typo, lost rivers, and underground drainage. Sinkholes are depressions that form in the surface because carbon dioxide in the water has dissolved rock underneath. Both of these pictures on the right are examples of sinkholes. One's on land, one's in a pond. Lost river, these form when surface streams disappear underground and flow out of caves many miles away. The Lost River in southern Idaho is an example of this. 14.3 review. This is questions 1 through 3 and 5 on page 311. Extra credit. If you have access to Netflix, go watch the series Our Planet episode Freshwater. Write down 5 interesting facts you learn. It's really cool. I love the series Our Planet. The cinematography is really good. Go write down 5 things that you learned. Either email to me or bring them to class when we're back in session, and I'll give you extra credit for you. Hope you guys are having a wonderful Monday. Talk to you later.